let's talk about something that's basically the secret glue holding our digital world together: hashing. You might not see it, but believe me, it's working all the time to keep you safe online. So let me ask you something. You log into stuff all day, right? But what if I told you that most secure websites have no idea what your password is? I mean, they never even store it. How is that possible? Sounds kind of crazy, but the answer is, well, it's really smart, and that's what we're going to unpack. First up, the password predicament. Yeah, to really get why the solution is so cool, you gotta understand just how big the problem is. Look, a password attack is one of the simplest ways for a hacker to get in. Imagine if a company just wrote down your password on their server. If they ever got hacked, and let's be real, companies get hacked, it would be an absolute disaster. The hackers would just have this perfect list of usernames and passwords. And you know how it is, most of us reuse passwords, right? So a leak from one place could mean your email, your bank, everything is suddenly at risk. It's a huge, huge problem. And this is one of their favorite tools, the brute force attack. It's exactly what it sounds like. A computer program just starts guessing passwords over and over and over, thousands of times a second. If you have a simple password, that thing is going to get cracked in minutes, maybe even seconds. See, this is exactly why just storing a password is a recipe for failure. Okay, so if storing the password is out, what's the alternative? What do you store instead? Well, this is where a really elegant idea from cryptography comes into play. It's called hashing. So what is hashing? Think of it like a super complex, one-way meat grinder for data. You feed it your password, and it churns it all up and spits out a totally scrambled, unrecognizable string of letters and numbers. That string is called a hash, and that is what websites store, not your password. This breaks it down perfectly. You start with your input, right? Your password. It goes into what's called a hashing function, this scrambler we're talking about. A super common one is SHA-256. Then, boom, out comes this fixed size hash. And that fixed size is really important for databases. Now, here are the two magic rules of hashing. One, the same password will always create the exact same hash, every single time. And two, and this is the really cool part, change just one tiny thing in the password, even just one letter, and the hash that comes out is completely, totally different. Unrecognizably different. And this right here is the absolute key. It's a one-way street. By design, you can go from password to hash, no problem. But going from the hash back to the password? Nope, can't be done. I mean, for all intents and purposes, it's basically impossible. It would take computers ages and ages to even try. Let's call hashing what it really is, a digital fingerprint. And to really get why that's so powerful, it helps to compare it to something you've probably heard more about, encryption. People mix these two up all the time, but they're not the same thing at all. Okay, this chart lays it out perfectly. Encryption, that's all about secrecy. It's a two-way street, you lock something up with a key, and then you need that key to unlock it and read it again. But look at hashing. Its purpose isn't secrecy, it's integrity. It's about making sure nothing has been messed with. And like we said, it's one way. No keys, no going back. I absolutely love this analogy. It just clicks. Encryption is like a safe. You put stuff in, you lock it, but you can always use the key to get the original stuff back out. Hashing is a blender. You throw in a banana, some strawberries, some yogurt, you hit the button, you get a smoothie. Now, try turning that smoothie back into a banana and strawberries. You can't. That's the whole point. It's a permanent change. All right, theory's cool, but let's see hashing in action. Where does this digital fingerprint actually show up in the real world? And here we go, we've come full circle. This is the answer to that puzzle from the beginning. When you go to log in, you type your password. The website takes what you typed, runs it through that same hashing function, and gets a new hash. Then all it does is compare that new hash to the one it has stored. If they match, you're in. It proves you knew the secret password, but the website never ever had to see it. It's just brilliant. But wait, there's more. Hashing is so much bigger than just passwords. Think about digital signatures on important documents. You can hash the entire document to create that unique fingerprint. If anyone changes even a single comma, the hash will change completely, and you'll know it's been messed with. Or how about when you download a big file? You ever see that long string of text called a checksum or hash on the download page? That's so you can check. You can hash the file you just downloaded and see if your result matches theirs. If it does, you know your download is perfect and hasn't been corrupted or infected with a virus. So,
Let's zoom out. What's the big takeaway here? Why does this whole thing matter so much?
When you boil it all down, it comes to this. Hashing is all about trust and integrity. It's the mathematical proof that something is what it says it is. It lets us know that our data hasn't been secretly changed. Without it, honestly, the internet as we know it couldn't function. We couldn't trust our logins, our bank transactions, our legal documents, nothing. It's a quiet but absolutely essential part of our digital foundation. So there you have it. From protecting your password to verifying huge files, hashing is this silent guardian, constantly checking and rechecking the integrity of our digital world. It kind of makes you wonder, right? What other brilliant, invisible little processes are humming away behind the scenes, just making everything work?